Okay, I'm going to try to give you a whole bunch of information about the culminating on this one video. Now, hopefully my microphone will work the whole video, but I didn't get a new one, so we'll see how it goes. Feel free to shoot me an email if there's missing information. Okay, so culminating. So I'm going to take you through the polynomial example that I had on the back page of the culminating and show you how to do it, and kind of show you how to use word and Desmos at the same time and do the tangent line, all in one super long video. Okay, so let's take our polynomial function, f of x equals x squared minus 4, or I put it in factored form too. So the culminating project asks you, this is just going to be a really rough version in Word here. You should try to make yours look good. So here's the polynomial function. So if I want to insert an equation, I can just go insert, and I can click on equation, and I can type in my polynomial function, f of x equals x squared minus 4. So you just use your keys, mine's shift 6 to get the exponent, like that little upside down V thing. And if it doesn't look like it's going, then you just hit space or just keep typing and it'll work. Okay, so my polynomial function, which sometimes gets moved to the middle of my page, so I just put it back to the left there, is f of x equals x squared minus 4. I've gone into Desmos and I've already graphed it here. So I want to take a screenshot of it now. So I'm going to insert screenshot, and I'm going to do a screen clipping. And I'm just going to highlight the important areas of my graph here. And then it'll import it into Word. I'm going to shrink it down to the size I want, and then I'm going to wrap text. I like to pick behind text, something that's just not going to get messed up. So there you go. There's our polynomial function. So in our culminating, graph each function, include all key aspects of the graph, intercepts, asymptotes, etc. Okay, so I should point out the vertex and stuff like that. So you can do this in whatever format you want. You can just talk about it. You could insert text boxes to kind of talk about key features of the graph. You want to say, well, I know the vertex of my graph is at 0, -4. So maybe I'll stick that in a text box and draw a line, an arrow to it, maybe. I'm not saying this is the way you have to do it. It's just like an option. So there's my vertex. Maybe I want to talk about the roots of my graph being another key feature. So maybe I'll just do another text box, and I'll say my roots are at -2 and 2. Yeah, I want to use another arrow that points to it. One root, and then the other root. And that's also my y-intercept there, so maybe I'll just add that in vertex, and maybe I'll just say somewhere here, y-intercept is at y equals -4. So maybe that's how I want to show my key features. If you want, you can do it like that. It's totally your call. Okay, so that's my polynomial function. So then I want to start answering the questions after I've graphed it and included key aspects. So I have to use algebra to determine when my function is equal to 4. Shoot. I hate when that happens. Okay, so that's annoying. Okay. Just just make this an even longer video. Move that stuff back up. Awesome. Alrighty. Okay. So function equal to 4. So I want to set my equation equal to 4. So I'm going to insert my equation, and I'm going to say x squared minus 4, and I'm going to set it equal to 4, because I'm going to try to find out when is my function equal to 4. And I'm just going to move that over. Okay, can I keep this going? I think sometimes you hit shift and enter. I'll let you just keep going with the equations. Okay, so in order to solve this, I'm going to move my -4 to the other side. Or I can move it, I can solve this in multiple ways. I showed one way on the back, maybe I'll show a different way. So I can move -4, actually no. Okay, so I'm going to move the 4 to the other side, so I'm going to add 4 to both sides, so it becomes x squared equals 8, right? So if I move that -4 to the other side, it's 4 plus 4. So I get x squared equals 8. And then I have to take the square root so I can find out what x equals. So x is equal to plus or minus the square root of 8. Because anytime you take the square root of something, it has to equal positive or minus that value. And then in the video, or sorry, on the back of the paper, I just showed how you could simplify your radical. So plus or minus, so root 8 can be split into root 4 times root 2, right? Because 4 times 2 equals 8, and then the square root of 4 is just 2. So we can write that as x equals plus or minus 2 root 2. And then if I have to show that on my graph, maybe I'll just copy this same graph down. Just shrink it a little bit. So if I want to show on my graph when my function's equal to 4, then I can just use an arrow or a highlighter or something. I could just point to those values when my equation's equal to 4. So I've got 2 values. Or maybe I want to circle it. A circle over it. Just change it to no fill. So you can show it in different ways, or if you can figure out how to highlight it, or however you want to do it, just show on your graph where it's equal to 4. Okay, then the next section you have to show when is your function greater than or equal to 5. Okay, so I'm going to stop showing you Word right now because I feel like that's how you do it in Word. I'm going to go back to OneNote. It's easier to write with. Okay, so we already showed that. So if we want to know when our function is greater than or equal to, or greater than 5, so we take our function, x squared minus 4, and then we just say when will it be greater than 5. So you can see right on the graph when it's greater than 5. Like our graph looks like this. So if we just look and find out where 5 is, then we know our function will be greater than 5 in those areas. Or if we want to show it using algebra, Okay, then we can solve this equation. So we can move everything to one side. So x squared minus 4, we're going to subtract 5 from both sides. So this will end up being minus 9. So we want our function, we want to isolate 0 like that. Or we want to make it, just put 0 on one side. Then I'm going to factor it to x minus 3, x plus 3. So then I solve for my roots. I find x is equal to 3 and x is equal to negative 3. So I know that's when my function is going to be greater than 5. At negative 3 and 3, my function is going to be 5 or more. So at those two values, f of x will be greater than 5. Okay, and then finally the last thing you have to do, so you have to do those three things, like graph it, key features, when is the function equal to 4 greater than 5 for all of them. And then just for the polynomial, you have to find the equation of the tangent line. Okay, so I'm going to show you how to do it officially and then unofficially. So, equation of our tangent line. So here's my function. Just remind you, it's f of x equals x squared minus 4. That's my function. And I want to find the tangent at negative 1. This equation of the tangent. So I have a point here, negative 1. So I'm probably going to have some kind of tangent line like this. And I want to find the equation of it. So first we're going to have to find the slope of it. So what we're trying to do is find the slope of this green function, x squared minus 4. So we're trying to find the slope of this function at this exact point. Because the slope of the green line is always changing, and we're just trying to find the slope at this one point, negative 1. And since we didn't really learn how to find the slope using just one point, one quick way to do it, like this is the easiest way, would be to just pick and point close to negative 1. So just pick negative 1 and then pick any other point that's really, really close to negative 1. So for example, we could pick the point negative 1, and we could pick the point negative 0.999 or something. So those 2 points are really close together. So we're almost finding the point at negative 1. So those are our x values, so we'll call that x2 and x1. And then if we want to find out what y2 and y1 will be, we just sub those x values into our equation, and then we can use our slope formula. So if I plug negative 1 into my equation, negative 1 squared is 1, minus 4 is 3. So my y values will be negative 3, and then if I sub in, I need a calculator, 0.999 negative squared minus 4, I get negative 3.001999. Oops. Okay, so those are my points. So now I'm just going to put them into my equation. So negative 3 minus negative 3.001999 by negative 1 minus negative 0.999. So I'm just finding the slope. So rise over run. And then if I subtract all those things, I figure out my numerator, my denominator, and then I divide them, I get negative 1.999, which is really, really close. Pretty much equals negative 2. So we're going to say the slope of our tangent is negative 2. If you want a super official way to do that, I'll show you. And if you don't care, then you can skip this next 5 minutes. Okay, so if our actual official way to do it is to call this random point, instead of picking an actual point like negative 0.999, we're going to call this value h. So it's a value that's really close to negative 1, like so close to negative 1, like 0.999 to infinity. So I'm going to make an equation for slope. So I know our slope equation is y2 minus y1 over x2 minus x1, but I'm just going to use f of x's right now. I'm going to say if our equation is going to be f of negative 1 plus h minus f of negative 1. And all that means is that's just like me saying, hey, that's f of negative 1, and this one's f of negative 0.999. So this value right here is just me adding on a random value like that I'm calling h. So I'm saying in my curve here, finding the point, I can't find the slope with just one point, so I'm picking a value here, and I'm calling the distance in between those points h, instead of like picking an actual number. And then we're going to subtract it by our x values. So our x values are negative 1 plus h minus negative 1. Okay, so then we just sub our actual values in. So f of negative 1 plus h, so we actually sub negative 1 plus h squared minus 4 into our equation. So that's like x squared minus 4 minus, and then we sub negative 1 into our equation. Remember, our original equation is x squared minus 4. That's my polynomial. So I subbed in negative 1 plus h in for x. And then if I sub in negative 1 for x, negative 1 squared is 1, minus 4 is negative 3. And the whole thing is divided by negative 1 plus h, and then those two negatives make a positive 1. Okay, so I'm just going to tidy some of this up. So negative 1 plus h squared, if I expand that, I get negative 1 plus h times negative 1 plus h. So if I actually really expand that binomial, then I get 1 minus 2h plus h squared minus 4 plus 3 would be negative 1. All divided by h, because these ones end up canceling each other out. And then if I can actually get rid of these ones, because 1 minus 1. So I just end up with negative 2h plus h squared over h. And then since every term has an h in it, I can actually cancel out an h from everyone, and I get negative 2 plus h. So my final slope ends up being negative 2 plus h, and h is the distance in between the points that we picked on our parabola, and we want the distance in between the points to be as close to 0 as possible. So we're going to say that if we actually want h to be as close to 0 as possible, we'll just eliminate it, and our slope ends up being negative 2, which is what you would have pretty much found out picking two really, really close points anyways. So that's what you have to do. You have to find the slope of your curve at that one point. So if you understand it this way, you just pick two values of x that are really close together, like these two exact values you can pick. You sub them into your equation to get y, then you just do y2 minus y1 over x2 minus x1. Or if you understand this crazy one with the h's that we'll be doing in calculus, you can use that method too. Okay, so that gets you the slope. And then to find the equation of your tangent, the equation of your line is y equals mx plus b. So you know your slope is negative 2. And then to figure out your y-intercept, you just have to choose another point. So if you look at my graph, using Desmos, I know there's a point negative 1, negative 3 on my graph. So I'm going to sub in a point, negative 1, negative 3. And I know my slope is negative 2. So I'm going to sub those values in. B to solve for my y-intercept. Okay, so it turns out my y-intercept is 5. So now I know the equation of my tangent line is y equals negative 2x minus 5. So that's my tangent line. Okay, let me know if you need any
other videos on your culminating.